Welcome back. Sorry. Let's solve some more word problems using trigonometry. All right, so let's read through the problem. Example 4, from the top of a lighthouse 165 feet above sea level, the measure of the angle of depression of a boat at sea is 35 degrees. Find to the nearest 100th foot the distance from the boat to the foot of the lighthouse. The first thing you want to do is draw a picture, okay, and interpret everything very carefully. So we have a lighthouse 165 feet above sea level. Right? So the top of the lighthouse is 165 feet above sea level. That's the height of the lighthouse. Right? So let's draw a lighthouse. And it doesn't matter how well you draw it. It doesn't even have to be very realistic. There we go. Here's our little lighthouse. They usually have stripes or something. There we go. So our lighthouse is 165 feet tall. The measure of the angle of depression of a boat at sea. So we've got a boat out here. Here's our boat. It's at sea. All right, so the measure of the angle of depression of a boat at sea is 35 degrees. Angle of depression looks down, right? So it's how you would have to lower your eyes. Right? So let's draw a triangle between the boat and the lighthouse and figure out where the angle of depression goes. All right? So the angle of depression, here's someone looking out. This is the angle of depression. So very important, the angle of depression is not inside the triangle. Right? Right, so it's how far you'd have to look down. So this right here is the angle of depression. This is where the 35-degree angle goes. Now you have one of two choices. You can remember that this C here, whatever the bottom of the triangle is, and somebody looking out are parallel lines, and that means this is going to be 35 degrees as well. Or you can find this angle over here. These two angles together equal 90 degrees. So if we call this one, we'll just call this one angle 1 and angle 2, right? So angle 1 plus angle 2 equals 90 degrees. They are complementary angles. So either find the angle that's the same measure, or you can just find this angle, which is going to be 55 degrees, because together 35 degrees plus 55 degrees equals 90 degrees. Either way is fine. All right? And we are so before we decide which angle we want, let's read the rest of the question here. All right, so find to the nearest 100th of a foot the distance from the boat to the foot of the lighthouse. So we're looking for this right here. All right, so we know, it's kind of hard to see here, or this is kind of blocking, but this is now it depends. If we use this angle here, this is the opposite side, and this is the adjacent side. If we use this angle here, then these two switch. Either way, you'll get exactly the same answer. All right? It won't make any difference. Since I've already switched them, let's use the 55-degree angle. All right, so tangent 55 equals, opposite is x, and adjacent is 165. Right? Now, you might like that equation better. That equation is a little easier to solve. The other equation, I drew my picture so big, I don't have any space to solve. The other equation, so if we switched and we used the 35-degree angle, it would have been tangent 35 equals 165, because that would have been the opposite, over x. That would have been the adjacent. So it is a little easier to solve if the variable's in the numerator. That may influence your decision on which angle you work with. The angle at the top of the lighthouse, which is complementary to the angle of depression, or the angle at the bottom of the lighthouse. So let's go ahead and solve. Let's multiply both sides by 165. So we have 165 tangent 55 equals x over 165 times 165. That cancels. That gives us 165 tangent 55 equals x. And then we can plug that into a calculator. That really doesn't take much space to solve, does it? As long as you don't draw your triangle so super, super huge. And I need to find the calculator, which is hiding on me. Calculator. So we have 55 tangent, and then times 165. So the distance between the boat and the lighthouse is 235.64 feet. And you might wonder, why would it be important? 0.64? Yeah, I don't know why I doubt myself. Why would it be important for the boat to know how far away it is from the lighthouse? Well, if this boat is too close to the lighthouse, guess what else it's too close to? It's too close to running ashore, and that will not be good. Right? Many a sailor is lost at sea by getting too close to shore. All right, so here's this one. So the only tricky thing on this particular problem, I think, well, first of all, you have to interpret the problem. Right? Draw a picture, and once you've drawn the picture, the problem is easy to solve. The other tricky thing on this one is where the angle of depression is. Right? So it's actually outside the triangle. Just find the complementary angle, and you can use that one. Or remember that the angle of depression is congruent to the angle of elevation, and you can use that one instead. All right, at a point on the ground 39 meters from the foot of a tree, the measure of the angle of elevation to the top of the tree is 42 degrees. Find the height of the tree to the nearest hundredth of a meter. All right, so this one I'm now going to draw smaller. All right, so we have a tree. A beautiful tree. All right, so, and at a point on the ground, 39 meters from a foot of a tree. Sometimes it helps to read something more than once. So we're on the ground. We have this point here that's 39 meters away from the tree. The measure of the angle of elevation to the top of the tree, angle of elevation looks up. All right, so that angle there is 42 degrees. I'm going to move that arrow. No, I guess I'm not going to move the arrow. Whoops. And there goes my eraser. All right, so this angle here is 42 degrees. Find the height of the tree to the nearest hundredth of a meter. So we are looking for the height of the tree. All right, so this is from the angle we're given. This is the opposite side. 39 meters is the adjacent side. So another tangent problem. All right, so we have tangent 42 equals x over 39. Multiply both sides by 39. So we have 39 tangent 42 equals x over 39 times 39. That cancels. So we have 39 tangent 42 equals x. And now we'll plug that into the calculator. So 42 tangent times 39. The tree is 35.12 feet tall. Right? So once you've got the problem written, it's no different than solving a side in any other triangle using trig ratios. Right? The tricky thing is interpreting. And the second part of your homework for trig word, it'll all be interpreting, where you have to draw a diagram. A school is 61 feet high. All right, so let's draw a school. School. I suppose it needs a door. There, now you can enter the school. And that's a doorknob. That is 61 feet high. Oops. Make that a little clearer. The distance to the road is 170 feet. All right, so when we are looking at the distance of a road, how far a road is, we're not going to measure it from the top of the building. We're going to measure it from the bottom of the building. All right, so this is 170 feet. And here's our road. Road. I don't know why the road buckled out. Road. And it just ends, apparently. I'm not too good at drawing three-dimensional here. All right, so what's the angle of depression from the top of the building to the road? All right, so the angle of depression right, so if someone were up here, the angle of depression is how far they'd have to look down to see the school. All right, so here they're looking down to see the school. Right here would be the angle of depression. So this angle here is the one we want to find. That angle there is the same as this angle here. All right? So angle of depression, I think, is a tricky thing because it's outside the triangle. But that angle right there is the same as this one here. Now, if it said the angle from the building, if it didn't use the word angle of depression, what if it said the angle from the top of the road to the building and it left out depression? Then it would be this angle here. All right, so this would just be the angle from the top of the school to the road. Because it says angle of depression, it's the angle that we have to look down. All right, so it's actually this angle that's outside. Now, I don't know in this problem if the person intended it to be the angle, I didn't write the question, angle from the top of the school to the road, but they use the word depression. We're going to find this angle over here because this angle and this angle are congruent. Those two angles are congruent. All right, and again, we've got tangent because we have the opposite side and the adjacent side. Right, so tangent theta, oh, and let me get rid of this theta because I shouldn't have the same variable in twice. We'll just put a question mark there. That angle there, that's the one from the top of the road to the school. But they've got the word depression, so we're going to find the angle of depression, which is outside the triangle. So tangent theta, so these two angles are congruent, right? So I can use this angle. Tangent theta is equal to the opposite, which is 61, over the adjacent, which is 170. All right, we take an arctan of both sides to isolate our variable. And by the way, if the homework includes angle of depression, I'll help you with that. All right, I'll just kind of remind you where it goes. right? Because that's a little bit tricky. All right, so theta is equal to arctan 61 over 170, and we'll just place that in a calculator. And we're done. All right, so 161, wait, not 161, just 61. 61 divided by 170 equals, and then second and tangent. So that would be 19, and we'll round that up, 19.74 degrees. Now, if they wanted this angle here, the angle from the top of the school to the road, that angle there, that question mark angle, would just be 90 minus 19.74. And so question mark there would be 70.26 degrees. So if you weren't sure, you could find them both and just call them different things, and then you got them both covered, right? And you can find that easily because the two angles add up to 180. Excuse me, the two angles add up to 90 degrees. Thinking of triangles. Angles in a triangle add up to 180. Two complementary angles add to 90 degrees. All right, so the angle of elevation to a building in the distance is 22 degrees. So we have a building. Angle of elevation looks up. Oops. There we go. Angle of elevation looks up. And then together, the building and the building, but that's not a very straight line, is it? The building, the ground, and looking up to the top of the building creates a triangle. Well, I just hit the board and made the screen go up. There. And I did not want to do that. I'll make this not so long. There, that's better. And of course, all these are right angles because things like buildings and lighthouses and schools are perpendicular to the ground. All right, so we know that the building is approximately 450 feet tall. Oh, and no, let's not forget to put the angle of elevation. The angle of elevation to the building in the distance is 22 degrees. So angle of elevation looks up. You know the building is approximately 450 feet tall. Estimate the distance to the base of the building to the nearest foot. Right? So we know the angle, we know how tall the building is, we want to find out how far we are away. All right? And lots of times we're looking at distances along the ground, and so tangent comes up a lot in these problems because we know the opposite and we're looking for the adjacent, and of course that's tangent. That's another tangent problem. So we have tangent 22 equals 450 divided by x. Multiply both sides by x. We have x tangent 22 equals 450 divided by x times x. X's will cancel. So I've got x tangent 22 equals 450. But our variable's not isolated yet. We're going to have to divide both sides by tangent 22. So we have x equals 450 divided by tangent 22. Let's plug that into a calculator. So clear this and get rid of that. So 450 divided by parentheses 22 tangent, close the parentheses, equals, all right, so we are 1,113.79 feet away. And we know the adjacent side is going to be a little larger, right, because 22 degrees is a pretty small angle. Smaller sides are opposite smaller angles. I forgot what I think it was 113.79, actually, now that I think about it. We'll see if I'm right when I go to use the calculator. If I'm wrong, I'll fix it. All right, let's solve another problem. I don't think I have too many left. I think this might be the last one. Yep, that's the last one. An airplane climbs at an angle of 15 degrees with the ground. Find the distance that it has traveled when it has attained an altitude of 1,000 feet. All right, so now we know where the angle is because it's with the ground, right? So if it says with the ground or against, something, then you know that's where you put the angle. We don't have to use the words elevation and depression. All right, so here is our mighty fine airplane. All right, it is climbing, which means it is going in the air. Now, when airplanes travel, they do not travel on the ground. There's a problem if your airplane is traveling on the ground or it hasn't taken off yet, right? Once it takes off, they don't travel on the ground. They travel in the air. So when we measure the distance that an airplane has traveled, it is not along the ground, it is in the air, right? The crew needs to know how far the plane's traveling so they know how much gas it's going to need. When is it or fuel? When does it need to fuel up again? All right. So when we're measuring the distance for the airplane, it's in the air, and this is very similar to a homework problem. I'll put that little note in there. On Trig word. All right. So it's climbing at an angle of 15 degrees. With the ground, find the distance it has traveled when it has attained an altitude of 1,000 feet. This is the altitude. So altitude is the height of the airplane. And for once, this is not a tangent problem, right? We know the opposite side. We are looking for the hypotenuse. Who uses opposite and hypotenuse? Well, of course, that's sine. So we have sine 15 equals 1,000 over x. Multiply both sides by x. We have x times sine 15 equals 1,000 over x times x. That will cancel. So x times sine 15 equals 1,000. We're not done because we have to divide both sides by sine 15. So x is equal to 1,000 divided by sine 15. Let's plug that into a calculator, and then we're done. And I was right on that number on the other problem. All right, so we have 1,000 divided by parentheses 15 sine close parentheses equals, and the plane has traveled 3,863.7 miles. Because it would round down on the second decimal. All right, so, and I can include more decimals if you like, but I think 2 will be all right. So 3,863.7. And there we go. All right, so the big key idea on these problems is first, draw a diagram. Second, make sure you understand the parts of the diagram. And if you have questions, let me know. All right, thanks for watching and have a great day.